testing research. And today I'm going to present a paper that we published last summer in software engineering, in empirical software engineering conference. So the title is An Empirical Study on Performance Bugs for Highly Configurable Software Systems. So first, I'm going to talk about the outline of my topic today. First, we're going to take a look at the motivation for our study. And then there I'm going to show an interesting motivating example that hopefully resolves some of the motivation questions that we had. And then we are moving on to our case study. There I'm going to talk about the research questions that we had while conducting the bug study, as well as various findings that we found. And then based on the findings, I'm going to talk about some of the implications for both researchers and practitioners. And lastly, I'm going to wrap up the talk by recap the major points that we have covered in the paper. So what motivates our study is by the following questions. First, we would like to know if performance issues would require a specific configuration to reproduce. If so, are they any different than the configuration bugs? And lastly, whether developers would need better techniques to handle such performance bugs. So hopefully I can answer some of these concerns in my motivating example. So here we're looking at the Apache Bug 54852. So in this bug, users report that occasionally when they issue a graceful restart, they have experienced some slowness. So upon further investment, it turned out to be that when Apache starts to gracefully restart, it involves a very expensive load, and it happens to be that the one configuration option, start servers, is used to control the number of the iterations for this load. Start server also represents the number of child server that's going to be started together when Apache starts. And the child server is used to handle HTTP requests. So what is so special about this bug here? First, in order to trigger this bug, we need one configuration item, that is the start servers. And also, this is not just any configuration option. This configuration option actually controls some of the most expensive performance code regions in the code. And lastly, it also has to be set to a relatively large number. For instance, if you set it to 60 and above, then you can start to see Apache might behave slowly when issuing the graceful restart. Okay, now that we have the motivating example, let's look at the research questions that we had while we were conducting the bug study. So the first research question we had was that how prevalent are performance bugs related to configurations? And next, we would like to see what are the types of configurations that could influence the performance. For the third research question, we would like to find out what are the potential causes for triggering the configuration-related performance bugs. And lastly, for the fourth research question, we want to see the complexity involved in fixing such performance bugs. As for our test subjects, we have selected 3 large open source projects. We pick these projects because they are very popular and they're actively maintained. We hope that by studying these popular projects, we can make our findings more meaningful. And so we have picked the web server Apache, the database engine MySQL server, as well as the web browser Firefox. We pick these large-scale applications also in the hope to have a better chance to observe performance problems, since performance issues is less severe in smaller scale applications. So to get our bugs, we first search against the bug repositories against a list of performance keywords such as slowness, sluggishness, throughput, and things of that sort. So originally we got 887 bugs because we want to also find out the effort involved in fixing these bugs. So we further filter out the bugs that have not been fixed. And so in the end, we got 193 out of the 887 bugs that have been fixed. And then we conducted some manual inspection to make sure that the selected bugs are actually both performance and configuration related. And as for the configuration space, we refer to configuration files as well as the online documentation to extract the configuration space. So there we had about 3,700 configuration options. And then we extensively studied 90 of them, which are related to the 113 bugs that we have studied.
It sounds to over 4,000. That's a minor issue. I can't help noticing that you somehow distinct the last but one column certainly is not 3,700.
Oh, this one?
Yeah.
You mean like this?
Yeah.
Okay. You might be right.
He's right.
Okay, but I mean, yeah, it's about
yeah,
that range. Right. I appreciate that.
Yeah.
Okay. So to answer the first research question, we found out that out of the 113 bugs that we have studied, about 59% of them are actually related to configuration settings. And it's interesting that compared to a previous general performance bug study, this number is about twice as high. For the second research question, I forgot to mention that as you can see in the pie chart for the configuration-related performance bugs, we further divided them into 3 subcategories, which I'm going to talk about in details here. So we have identified the parameter configurations. This is the type of configurations that you normally see in the configuration files. We have also identified the hidden configurations. This is normally used as the variables, but serving as a way to control how program behaves throughout the code base. And for the third type, we define the system level configurations. This one talks about configurations such as the system topology, as well as the software components and libraries that might be involved. We also look at how some of the individual values might have affect the performance performance bugs, because previous studies have reported that certain enumerate values could cause certain bugs. But in our case, we didn't see any such bugs. There are two primary reasons for this. The first one, because we are dealing with performance bugs, and normally the illegal parameters would have caused the applications to either fail to start or crash, which would in turn consider functional bugs, not performance bugs. And secondly, because we have studied these well-known project which has been there for such a long time that they have developed a mechanism to prevent the illegal option values to come into the system. And we believe that's why we didn't see any in our case. And here I have some statistics for the bugs that fall into each category. So in table 2, we can see that about 80% of the bugs that fall into the parameter configuration type. And for the system-specific ones, it's sort of less, about 8% to 70%, but still not trivial. And for the hidden parameters, there's only a very small portion, about 3%. And we also studied the number of options involved in each of these performance bugs. And if we can see in table 3, we found that the majority of the studied parameters, about 72%, are only involved with one configuration option. Next, we divide the parameter configuration types into 5 categories. So we have the memory, network, I/O, concurrency, and graphics. And we have summarized the configuration bugs that fall into each of these categories in table 4. And it turned out that about 70% of the parameter configuration bugs fall into the memory and network category.
In the specific case of Apache and the number of children, which of those categories is that bug in? It's certainly configuration.
The number of children, you're talking about the start servers, right?
Yes.
Yeah, I think that falls into the network category because it controls the number of the child server, which is going to use to handle HTTP requests, which involves the network traffic and such. And as for the system level configuration, we have identified 3 categories, the environment, hardware, and components. And we found that about 70% of the system configurations involve incompatible components of libraries. For our third research question, we would like to see when the performance bugs were introduced. So we look at the bug, and then we found that there is 3 occasions where performance bug could be triggered. So here we define first time, runtime, and upgrade. First time refers to the initial time that a configuration option that is being loaded. And runtime refers to the system that supports the on-the-go changing of configuration values, such as Firefox. For instance, you could change some configuration settings without restarting the application. And lastly, we define the upgrade category, which talks about the here, actually, we leverage some of the internal symptoms, such as the memory and CPU usage, as well as the synchronization options. And then we associate these internal symptoms with the configuration domains. So we found that about 35% of the bugs were caused by insufficient memory usage, and about 70% resulted from high CPU utilization, and about 40% were related to synchronizations.
Again, looking at your example from Apache,
Right.
Which kind of reason did you associate there?
Right. This one is, well, this one,
I can imagine it could be either memory or CPU or synchronization.
that could be the case. The main purpose of having this association listed was that in the hope that by observing how the program behaves, you could have some guess to reduce the scope of the type of configuration options to look at. For instance, if you might see some memory spikes, then you only need to look at the configurations that might have related to configuration, related to memory settings. Right. So, and lastly, for the last research question, we have studied to find out what has been involved in trying to fix the performance bugs from the supported patches. So in table 8, we have identified a few factors. As we can see, some of those can be fixed by tweaking the configuration option values, while others will require some source code changes. And there's a small number of bugs that would require both. So in the end, we found that about 88% of the bugs would involve code fixing. And also, based on our study, we get different conclusions from a previous general performance bug study, where they claim that performance bugs would normally require 5 lines or less to fix. So here we found that about 65% of our study bugs would require at least 30 lines or above to get them fixed. So based on the findings, we have some thoughts for practitioners. First, performance testing should consider key configurations. Here in reality, the configuration-aware testing techniques is very expensive, mainly because even if you have a small application that only has a few configurations, but the combinations among these options could grow exponentially, which is also known as the configuration space exploring problem. So here, with our study, we found that in terms of performance, there's only a small portion of the configurations that might actually have something to do with the performance aspects of the testing. So we were hoping that by leveraging our research, there could be tools to prioritize configuration options first, so as to reduce the scope of the configuration space. And second, for system-level configurations, they're very important in the sense that sometimes when developers are trying to fix a problem, they might only looking at their application level and ignore the bigger picture, which is on the system level. So, so the lesson here is, you have to sometimes look outside the application scope and not to ignore configuration that could affect your environment. And third, profiling is very useful for identifying these configurations. And by far, profilers are still the most widely used methods for helping developers to pinpoint a performance problem. And while we are looking at, we have associated the internal symptoms with various configuration domains. We were hoping to use that knowledge to reduce the scope for developers to look at, and so that they might be able to pinpoint the performance problems faster. And as for researchers, first, testing and debugging tools are still needed. The current state-of-the-art testing still involves test case generation and test articles. So here, for test case generation, we were thinking that we might be able to leverage the static analysis techniques to pinpoint the code regions that could be positively impacted by configuration items, and use that information to feed back to the test engine, to guide the test engine to generate test inputs that could more efficiently expose performance bugs. And for the test articles, we've seen some research, the researchers using machine learning techniques to build models to help them to tell if, in certain cases, whether there's a performance bug or not in the subject enter task. And as for the debugging tools, currently there's most tools will associate the performance problem with the code base, but not with the configuration aspect of the program. And for configuration-aware regression performance testing, right now the current practice is that for regression testing, it focuses on only the functional. It focuses only on targeting on the functional bugs, but not the performance bugs. As well as we normally treat the configuration as something that is static, not something that could be changed. And for building performance influence configuration models is still very challenging. There are two parts to this one. The first one is reducing the size of the learning set is an element question. And secondly, for the black box configuration modeling methods, being able to effectively identify the interactions between configurations is not trivial at all. And for fixing and avoiding performance bugs, we would hope to see a system that could adopt the self-adaptive software system. So that means that the system could watch for certain performance metrics to determine when the system should take action to change some of the configuration, performance-related configuration options to adjust itself to adapt to the new environment changes to either improve performance or to avoid a system crash. And lastly, inferring new configuration tools are desired. We have seen techniques that could extract configurations from existing code bases, but during our study, we have seen there are a few cases where the developers have to introduce new configurations to get the problem fixed. So that's where the current technology fell short of. Okay, to sum up, we have conducted a first empirical study in the context of highly configurable systems. We have studied 130 performance bugs that's all induced by configuration settings. And also our study covers various characteristics of the performance bugs. Things like when they're being introduced, what could be the possible cause of such performance bugs, and some of the performance bug types distribution. And lastly, we have provided some insights and suggestions to those practitioners and researchers. And that is all. Thank you.
We have a few minutes for questions if somebody would like to ask a question.
You mentioned previous study, for instance, for the research question 1.
Right.
Your results differ dramatically from the results of the previous study.
Yeah.
Why are they wrong?
No, because I think it's because we believe that in the highly configurable type of system, you might have a different.
Okay, so they were not considering the same type of configurable setting.
Right, they don't care much about the configuration aspect of the applications. That's I think that makes the sample space different.
Okay, and you made a similar comment in the context of research question 4.
Right.
And the reason is the same. The studies are different, well,
Yes. So we were hoping to show that within a different context, the conclusion could be like dramatically different.
Other questions? Well, I have a simple question.
Yeah.
There are different kinds of configuration settings. One is numeric. How many of these do you want? 1, 2, 3, 10? Another is Boolean. Is this turned on or is this feature turned off? Another would just be a specification like use this file instead of that file. Do you have any feeling for which of those kinds of configuration settings are most likely to cause performance bugs?
I think most of the existing research they focus on the either the binary ones or the numerical ones.
Because it seems to be that a numerical one, putting it at the end of its possible range, is more likely to
Right.
cause a bug.
That's true. We have seen bugs that's involved with the size of the caching, which you give it a number for determining the size of the cache, and if you set it too small, too big, that could both cause performance problems. So yeah, and also that there is the opportunity for investing in other types of configurations, such as for the configurations that only taking a literal string. I'm not saying that it couldn't cause a problem. As a matter of fact, it could, because sometimes certain configurations might ask for a IP address, which I